Hi students, today we are starting with the third chapter of +1 chemistry, that is classification of elements and periodicity in the properties. So the topic we are starting is, before going to learn this chapter, I want you to tell me some answers of the questions I'm asking. Do you think that alphabets are necessary to learn any language? So I think the answer is yes, because before knowing the language, you should be knowing the alphabets. So yes. Okay. अगर किसी को तेलुगु सीखना है तो उसको तेलुगु अल्फाबेट समझ में आना चाहिए. If anyone is going to learn English, उसको इंग्लिश का अल्फाबेट्स आना चाहिए. And similarly, if we want to learn the language of chemistry, we should know the periodic table. So based on this fact, some scientists considered chemistry as a language and periodic table as its alphabet chart. So a common growth of human. So in the same manner, there is a gradual growth in chemistry with the discovery of elements. So as we keep on knowing the elements, we can gradually understand how the elements behave. So in 1800s, only 31 elements were discovered. Only 31 elements were known. Then after 65 years, we were able to identify 63 elements. And at present, we have 114 elements known. So we know such a bulk amount of elements, so we should understand the properties of the elements easily. They are classified systematically. तो जितना आप easily properties को समझ पाएंगे, उतना easily हम classify कर पाएंगे अपनी periodic tables को. So now why we are reading this chapter? To understand the need of classification, that why we need to classify the elements. To understand the present form of periodic table, how we are classifying the elements into S, P, D, F blocks, and the periodic trends of the elements. कि उनकी properties कैसे trend करती हैं, उनका क्या period है. So let us start with the genesis of periodic classification. So why do we need to classify elements? What is the need? What is the purpose of classifying the elements? So at present, 114 elements are known, and it is very difficult to study all the elements at same time. आप एक साथ बहुत सारे elements को नहीं पढ़ पाएंगे, confusions हो जाती हैं या समझ नहीं आती है. So to understand the properties of the element easily, we should classify them systematically. So the classification starts with number 1. It is Daubnier's law of trade. So सबसे पहले Daubnier he started with this. Then Newland's law of octave. Then we have Lothar-Mayer's periodic table, Mendeleev periodic table, and modern periodic table. ये वो table है जिसको हम अभी भी use करते हैं. So let us first start with the Daubnier's law of trade. So what is a trait? Trait means group of 3. So Daubnier gave us the law of trait so he was a German chemist, and he gave this law in 1829. So he noted certain similar properties of several groups of 3 elements. तो इन्होंने क्या देखा, that some 3 elements are having certain same properties. We were having some same properties. So उन्होंने देखा. So according to this law, in a trait, the middle element had the properties average to that of first and the third element. तो उन्होंने यहाँ पे क्या देखा कि अगर हम 3 elements का set लेते हैं, तो जो middle वाला element है, उसका जो properties हैं, they are average of first and third element property. So lithium, sodium, and potassium. So let us take the atomic weight. So the atomic weight of first and third, उसका जब आप average लेंगे, that will be the atomic weight of middle element. So this is how the law worked. So he made some other traits also, like calcium, strontium, and barium. So, and chlorine, bromine, and iodine. So if you take their masses, like 40 plus 137 divided by 2 will approximately give us 88. Similarly, 35 and 127 का average लेंगे, so we will get approximately 80. So this is how he discovered the group of three elements which have certain relationships in their atomic weights. Then they had some drawbacks also. So drawbacks were only few elements were known at that time, because very few elements were known, around only 31. So it was difficult to arrange the elements in group of three. एग्जाम्पल आयरन कोबाल्ट एंड निकल को जब अरेंज किया तो उन्होंने वो पैरामीटर्स शो नहीं किए. सो दिस वाज अ ड्रॉबैक. So this law was disapproved. This law was abandoned. The people they were not looking into this law anymore. So let us do some question based on this law. Okay, what is a trait? So the answer is group of three. Okay, then we have drawback. What were the drawbacks of Dobnier? So only few elements were known, same atomic weight, both, and none of these. So answer is none of these. Only few elements were known, and mostly there were few elements जिनका same atomic weight था. Okay, then we have Newland's law of octave and Lothar-Mayer's periodic table. So let us start with this. So Newland, he gave a law of octave. So what was octave? जैसे डॉबनियर ने ट्रेट बनाया लाइक ग्रुप ऑफ थ्री, वैसे ही ऑक्टेव मींस 8 नोड्स ऑफ म्यूजिक. सो ही स्टार्टेड विद 8 एलिमेंट सिस्टम. सो ही गेव दिस लॉ इन 1865. सो क्या था ये लॉ? दैट एलिमेंट्स वर अरेंज्ड इन ऑर्डर ऑफ देयर इंक्रीजिंग एटॉमिक वेट्स. जब आप एलिमेंट्स को उनके इंक्रीजिंग एटॉमिक वेट्स पे अरेंज करेंगे, so the eighth element will have similar properties as that of first element. So this is called the law of octave, that when the elements are arranged as per their atomic weight, the eighth element will have same property as that of first element. So it was just like the musical scale. Sa re ga ma pa dha ni sa. So this is how he arranged the table, and he saw that elements were same, but there were some drawbacks. It was observed up to calcium only. ये जो law of octave था कि eighth element और first element का property same होगा, this was only till calcium. उसके बाद ये rule आगे नहीं चला after 40 atomic mass. So this was again disproved. Then we have Lothar-Mayer's periodic table. So he classified the elements again on the basis of atomic weight. So what he did is he plotted the physical properties like atomic weight, melting point, boiling point against atomic weight, right? Sorry, मैंने यहाँ पे weight बोला. It is volume. So he arranged volume, melting points, boiling points versus atomic weight. उन्होंने इसका ग्राफ प्लॉट किया, but it was not published before the work of Mendeleev periodic table. तो जब मेंडलीव का टेबल आया तो इनके वर्क को पब्लिश ही नहीं किया गया. So Newland has arranged the elements in the order of their increasing what? Atomic numbers, atomic weights. Okay, so we have atomic weight. What is meant by octave? Very simple. 8. Newland's law of octave is observed up to only calcium. Mendeleev's periodic table. So now comes the big hero, Mendeleev. So Mendeleev was a Russian chemist, and he states that property of the element are periodic functions of their atomic weights. So he constructed the first periodic table, which is known as short form of periodic table. So this is how his table looked like. So he has arranged the elements as per their chemical properties. So he had made some series and they are starting from 0 to 8. And if you go down, it is from 1 to 12. So he arranged certain elements as per their chemical properties. So he said that if element is R, so when it will form oxides, it can form an oxide of R2O, RO, R2O3, and so on, higher oxides and all. So he arranged these elements as per their chemical properties also. So the vertical columns are known as groups, which are total 9 in number because this starts from 0. And the horizontal rows are called periods, which are total 7. So further, the groups were divided into A and B, जिसको हम subgroups बोलते हैं. And the 8th group consists of mostly transition elements. So what are the merits of Mendelevian periodic table? So he gave some elaborations on the classification of elements based on their physical and chemical properties. So उन्होंने जो भी अपना classification दिया, periodicity दिया, that was on physical and chemical properties. And the very important merit is he predicted the existence of unknown elements and left some gap naming them as एका elements. तो उनको जब उन्होंने स्टडी किया उनको पता चला कि अभी बहुत सारे elements जो हैं which are unknown. So he wisely left some gap for them and he named them एका elements. तो आपने सुना होगा एका aluminium, right? So examples are like this: scandium. So he wrote scandium की जगह पे उन्होंने लिखा एका boron. It means that scandium has properties of boron also. वहीं पे उन्होंने गैलियम मार्क किया as एका aluminium. मतलब गैलियम has properties similar to aluminium. Then germanium is एका silicon. And he corrected the atomic weights of beryllium and indium. With the formula is atomic weight is equal to equivalent weight into valency. But Mendeleev again had some drawbacks. So let us see his drawbacks. So some elements with higher atomic weight were placed before low atomic weight. So order तो था increasing का, but यहाँ पे कुछ गड़बड़ हुआ that higher atomic numbers were arranged before low atomic numbers in order to maintain similar chemical nature. तो इन्होंने ज़्यादा focus किस पे किया? He focused more on the chemical nature rather than atomic weight. So this was the drawback, and these pairs are called inverted pairs. Inverted pairs means higher atomic weight before and lower atomic weight later on, right? Example, argon and potassium. So they should be arranged in the other way around. Then cobalt and nickel, same weight. Beryllium and iodine. So they were all inverted pairs. So the place of elements in groups also changed. तो क्योंकि atomic weight के basis पे किया था तो इनका group भी change हो गया and position of hydrogen was not made clear. So at that time, hydrogen was having no specific position and lanthanoids were uncertain. Mendeleev was not knowing about lanthanoids कि उनको कहाँ पे डाला जाए. So ये सब क्या हैं? ये सब Mendeleev के drawbacks हैं उनके काम के. Okay, so we have some MCQs to solve. So Mendeleev's periodic table was based on atomic weight. Okay, consider the chemical properties. Atomic weight of elements was corrected based on. So the atomic weights were based on valencies. The element scandium is known long back as. Scandium को क्या बोलते थे? It was like एका boron. एका silicon is known as what? It is known as germanium. So then we have the modern periodic table. So modern periodic table किन्होंने दिया था? Henry Moseley ने, and what was he in 1913 he was English physicist, observed regularities in characteristic X-ray spectra of element. तो इन्होंने जो periodic table दिया, it was experimentally based. He studied X-ray spectra, elements का X-ray spectra study करके he designed the modern periodic table. So he made this table on the basis of atomic number, and the relationship is under root V is equal to A Z minus B. So where A and B are constants and Z we know it is atomic number. So modern periodic law जो है इसमें ये क्या बोलते हैं that the physical and chemical properties of the elements are periodic functions of their atomic number and electronic configuration. It means that whenever we are studying any physical and chemical characteristic of any element, it is based on two parts. Number one is atomic number and second is electronic configurations. So इन दोनों properties का जो periodic function है that helps us to understand the physical and chemical characteristics of the elements. So modern periodic table, also known as long form of periodic table. So this is how it looks like. So here hydrogen is placed at first position and you can see different rows and columns with different colors on them. So this is how modern periodic table looks like. So it contains total 7 periods which are horizontally arranged, 18 groups which are basically vertical columns because table है तो rows and columns की form में होगा. The older notations of group are, अगर हम पहले की बात करें तो रोमन नंबर्स में हमने इनको क्लासिफाई किया था 1A, 2A, 3B, 4B, 5B, 6B, 7B, then 3 groups with 8 and so on. So then we have IUPAC naming, which is International Union of Pure and Applied Chemistry. तो उन्होंने इसका नंबरिंग चेंज किया and they named it as 1 to 18 group number, directly 1, 2, 3, 4 and so on, right? So period number, how to find out location of any element. So if you want to know the period number, अगर आप उस element का electronic configuration लिखते हैं तो highest quantum number. For example, if I take sodium, the configuration is 1s2, 2s2, 2p6 and 3s1. So in this case, the highest quantum number is 3. So it means that sodium belongs to third period. So this is how we can calculate the period of any element on the basis of electronic configuration. So important points about modern periodic table is that the first period, total it has how many periods? 7 periods, out of which the first period contains only 2 elements, that is hydrogen and helium. Okay, the remaining periods, that is 2, 3, 4, 5 and 6, they contains 8, 8, 18, 18 and 32. So अगर हम इसको sum up करें, that we have total 7 periods. So how many elements are there as per periodic table? The first period contains 2 and then we have 8, 8 and then 18, 18 and then 32 and 32 only है ना. 7th की बात ही नहीं किया यहाँ पे, 6 की बात की है. So 32. So the 7th period is incomplete. It is still incomplete. 14 elements of both 6th and 7th period are placed in the F block, which is lanthanoids and actinoids. So this is first period, which contains only hydrogen and helium. So if I talk about second period, it is from lithium till neon. So total, if you can count, there are 8 elements. Then moving to third period again, 11 to 18, sodium to argon. Then fourth period again, यहाँ पे आपके पास आ जाते हैं 18 elements. Fifth period again, same 18 elements. Sixth and 7th, they contain 32 elements each. So what is the difference in the approach between Mendeleev's periodic table and modern periodic table? What are the differences? The first difference is that Mendeleev periodic table, he worked on atomic weights, whereas modern periodic table worked on atomic numbers. Okay, second question is, which element do you think would have been named by? सो लॉरेंस बर्कली लेबोरेटरी ने नेम किया लॉरेंसियम, एंड सीबॉक ग्रुप का एलिमेंट क्या है? सीबॉर्गियम, विच इज 106. Okay, now the period that contains only gaseous elements. कौन से पीरियड में सिर्फ gaseous elements हैं? So the answer is first, because first period contains hydrogen and helium, hydrogen gas and helium gas. So these are all gaseous compounds. The period that includes all type of elements is सिक्स्थ पीरियड. इसमें मेटल्स भी हैं, इसमें नॉन मेटल्स भी हैं. ठीक है, ये इसमें सब कुछ मिलेगा आपको सिक्स्थ में. Longest and shortest periods are, okay, the longest one is sixth and the shortest is first. Atomic number of nitrogen is 7. The atomic number of third period in the same family is, ठीक है, वो बोल रहे हैं कि नाइट्रोजन का अटोमिक नंबर है 7. सो इसी फैमिली में, मतलब सेम ग्रुप में, दिस इज फर्स्ट, सेकेंड एंड थर्ड, इसका अटोमिक नंबर क्या होगा? तो आपको पता है नाइट्रोजन बिलोंग्स टू सेकेंड पीरियड, इसमें 8 एलिमेंट्स हैं. देन थर्ड में 18 एलिमेंट्स हैं, एंड फोर्थ में भी 18 एलिमेंट्स हैं. सो यू नीड टू काउंट इट एंड टेल, राइट? So the answer is 33. So the topic is over. Thank you for listening.